No. Right. So today is the final webinar before you submit assignment number 4. So it is due this Sunday, both physics and maths. And today I'm going to go through some more questions, but mostly I'd like to get some feedback from you. Like, what would you like to discuss today? I have some questions prepared. We'll go through them first, and then feel free to ask any questions, even if they're not directly related to the topic. So I'm happy to answer. So let's get to it. So I will start. Sharing my screen. Okay, so problem 1. A projectile is launched with speed u at an angle of 30 degrees. At the highest point, it breaks into 2 equal parts, traveling horizontally. So a diagram always helps. So always start with a diagram. So we have a projectile launched at an angle, and at the highest point, it breaks into two fragments. One is traveling to the right, and one is traveling to the left. How do we know that they travel in this direction? Because the first part hits the ground exactly at the point of launch. So basically, if the projectile was traveling with speed v, that means this part is traveling with a speed v to the left. And if it continued traveling, it would travel like this. But because it breaks into 2 pieces, so we have one part traveling back to the point of launch, and another part, well, probably it means it travels further. Because we have conservation of momentum. I know conservation of momentum is the next topic, but intuitively you should understand that. Yeah, that if this part travels backwards, this will travel forwards faster. Okay, so this is 0, 0. This is the original point of launch. This is the y-axis. This is the x-axis. Well, what do we know? Well, we know the theorem of motion of the center of mass, which says that with the center of mass of the system continues to travel the same way as the center of mass of the system travels the same way as the initial system. So the center of mass continues traveling along the black path. So let's label it path of center of mass. And that makes the problem super easy, because as a matter of fact, if the center of mass is here and we have 2 equal parts, and the first part is here at 0, let's say this is at a distance L, where is the second part? If the center of mass is at L, where will the second part land? Can somebody help me? 2L, of course. 2L. So the second part will travel a distance of 2L. 2L. All right. So all we need is to find L. And we're good. And to find L, we don't need to consider the two paths breaking into halves. We just consider the original path. So to find L, so we know that the projectile was launched at 30 degrees with a speed u. So the horizontal speed is u cos 30. And the vertical speed is u sine 30. Or in other words, half u, because sine 30 is a half. Okay. So we need to find the time of flight. To find the time of flight, we write a suvat for the vertical motion. Suvat. So t is what we're looking for. Acceleration is minus g. Final velocity we don't know, and we don't actually need it. Initial velocity is half u, or u sine 30. Well, u sine 30, half u. You know what? I'll write u sine 30, just for the sake of it. U sine 30. Sine 30. And s is 0, as a matter of fact, because it starts at y position 0. Yeah, because we're only doing the y direction. So s is 0. The vertical displacement is 0. So we choose a suitable equation. The suitable equation is s is equal to ut plus 1/2 at squared. And that makes it 0 equals u, which is u sine 30, t plus minus 1/2 g, okay, minus 1/2 g t squared. Now we are allowed to divide by t because we know t is not 0. So we divide by t, yeah, because t is not 0, and we get u sine 30 equals to 1/2 gt. So t is equal to 2 u sine 30 divided by g. Perfect. We have the time of flight, and all we need is the horizontal displacement. So now we consider the horizontal motion, the x direction. So this is the motion in the y direction, this is in the x direction. So we know that the horizontal displacement is equal to the initial horizontal velocity times time, which is u cos 30 multiplied by t, and sx is u cos 30. So it's this times this. So it's going to be u cos 30 multiplied by 2u sine 30 divided by g. So, and this is L, yeah, because we know that this is L. So L is equal to 2u squared cos 30 sine 30 divided by g. And we know that 2 cos 30 sine 30 is cos 60. So it's u squared, sorry, sine 60 divided by g. So that is that sine 60 is square root of 3 over 2. So square root of 3 u squared over 2g. That is the horizontal displacement. Therefore, the second piece, so the answer is double that. So 2L is equal to square root of 3 u squared divided by g. Square root of 3 u squared divided by g. Notice that I didn't substitute g because I still have an unknown in my answer, which is u. So I'm leaving the answer as like this. So a seemingly complicated problem becomes super easy once you understand the physics. And when you understand that the center of mass continues traveling, and the center of mass of 2 equal pieces is here, therefore one piece is here, one piece is here. You will have a similar question in assignment 5, which you can do in 2 different ways. You can do it in using momentum, or you can use the center of mass of the system. Okay, a man mass 60 kilograms walks from one end of a boat mass 100 kilograms to the other. Find the displacement of the boat. Okay, so in order to walk to the right, the person needs to apply a force on the boat to the left. So to understand the physics, so when you walk, you push the ground backwards and the ground pushes you forward. And this allows us to understand why the boat would move in the first place. There's a force on the boat and there's an equal and opposite force on the man. Therefore, the man can walk forward, but there's a force on the boat, and that means that the boat will move backwards. If you ever walked on boats, on light boats, you know that when you walk on it, the boat moves. You can ignoring resistive forces here. So let's find the center of mass of the man-boat system. So we choose a convenient coordinate system. So I would say put the man at 0. It doesn't really matter where you choose. The man is at 0. The center of the mass of the boat is 1.5 because it's a 3-meter boat. And here is 3 meters. Okay. So what happens? The person walks a distance, but the boat shifts to the left. So if the boat shifts by L meters, so the new position of the boat would be, so this would be minus L, and the new position of the man would be 3 minus L. So boat, man, old and new position. Initially the boat is at 1.5 and the man is at 0. The new position of the boat is 1.5 minus L. So the boat has shifted, the boat has moved. 1.5 minus L. The man would be at 3 minus L. Okay. So let's find the center of mass. Center of mass. Sorry, not like this. The center of mass. The center of mass. The old position of the center of mass must match the new position of the center of mass. So X center of mass old, let's call it like this, is 60 times 0 plus 1.5 times 100 That's the mass of the boat divided by 160. 160. So that is 150 times divided by 160, which is approximately 15 over 16 is 0.9375 meters. That's the position, that's the initial position on the center of mass of the system. 375. And of course, we need the new position, but the center of mass could not have moved because there are no forces. So we can ignore resistive forces. Therefore, the center of mass has not moved. The new position of the center of mass has to be 9375 meters. So X center of mass new position is going to be 60 times 3 minus L plus 100 times 1.5 minus L divided by 160. And that has to be equal to, instead of 0.9375, I'm going to use this. It has to be equal to 150 divided by 160. In this way, this makes my life easier. And from here, I get rid of the denominator. I get 60 times 3 minus L plus 100 times 1.5 minus L equals 150. So 180 minus 60L plus 150 minus 100L equals 150. 150 cancels. And if there's 160L equals 180. So L is equal to 180 divided by 160. 1.125 meters. So the boat has shifted by 1.125 meters. And this is the answer. Any questions here? So the center of mass used to be somewhere. Well, I'll make another drawing. The center of mass used to be here. Now, some bit later, the boat has shifted to the left, and the man is standing on the right. But the center of mass should still be at the same location. So the man moves to the left, the boat moves to the man moves to the right, the boat moves to the left, the center of mass stays where it is. Fundamentally, you cannot change the position of the center of mass using only internal forces. And this leads to quite a peculiar situation. Imagine a rocket in space. Imagine a rocket in space. It has some fuel inside. This is the fuel. And let's say the rocket is stationary. The rocket is stationary. So the center of mass of the rocket is somewhere here. Yeah, the center of mass of the rocket is here. Now the rocket expels the fuel from the back. So the fuel moves to the left, but the rocket moves to the right. I'm going to be a little bit lazy and I'm going to draw it here. And the fuel fuel moves. The fuel moves to the left, and the rocket moves to the right. But the center of mass can only move if there are external forces, and if there are no external forces, the center of mass of the rocket remains where it is. The fuel goes to one way, the rocket goes the other, but the center of mass stays where it is. So if you ask, where is the center of mass of the rocket? If the rocket goes from the Earth to the moon, you can say it's on Earth. It's at the point of launch. Well, of course, the exhaust gases hit the ground at some point, and of course, some of the exhaust gases will be stopped by the Earth's atmosphere. So of course there's some variation, but in an ideal scenario, if a rocket fires its engines, the center of mass remains where it is, because the center of mass cannot move if there are no external forces. Okay, another similar question in a way. So just to get you super familiar with these questions. A smooth wedge ABC of mass m. So okay, so this is a wedge of mass m, is placed on a smooth table, so no friction. Another wedge BED is placed on top and released. Find the position of the lower wedge when the point D reaches point C. So basically what happens is that the top wedge slides down, and because it's moving to the right and the center of mass must remain where it is, there are no external forces. Therefore, the lower wedge has to move to the left. Okay, so how does that work? Well, these are prisms. These are prisms, and you know from the assignment that the center of mass of a triangle is 1/3 of the way from the base to the highest point. So the center of mass of the lower prism is 1/3 A. 1/3 A. So for convenience, we'll take this as 0. And we're only interested in the horizontal position of the center of mass, of course. So X 1/3 A. And the position of the top block is 2/3 B, because it's the other way around. 2/3 B. This is the distance. Okay, so this is the position. The position of the center of mass. So X center of mass is equal to mass, big mass, times 1/3 A plus small mass times 2/3 B divided by m plus m. There's not much you can do here in terms of simplifying, but I'll try. So 3, take the 3 down, plus m, ma plus 2mb. Just slightly pretty and not necessarily simpler. Okay, so the top block moves to the right, but the center of mass must remain where it is. So we'll use a similar approach. We'll draw the top, bottom, and center of mass before and after. So assume that the top block, once again, has shifted to the left by L to the left. So the top block, so how far is it allowed to move? Well, it's A minus B, that's the distance it can travel, A minus B and minus L. So the top block, before it was 2/3 B. Now it has shifted by A minus B. But then it's shifted to the left by L. So it's going to be the initial position, 2/3 B. Then it shifted to the left by L, and it shifted to the right by A minus B. I know, confusing. Yeah. Do you understand this, guys? Type from 1 to 10 if you understand this, where this expression comes from. If you don't understand, type something like 1 or 0. So it used to be at a position, so this distance is B minus A. So this block started off from 2/3 B. The center of mass of this block started from 2/3 B. Then it moved to the right by B minus A. But then the whole thing shifted to the left by L minus L. And that's where this thing comes from. 2/3 B minus L plus, sorry, A minus B. Sorry, A minus B. A minus B. A minus B. Okay, the bottom block. It started off at 1/3 A, and it finished at 1/3 A minus L. It's a bit simpler. The center of mass stayed where it is, so the center of mass is the same. Okay, so it's MA plus 2MB 3M plus M, and it's the same here. It's the same here. So the X center of mass after is equal to the mass, the bottom block, times 1/3 A minus L, plus the top block, which is at a position, so 2/3 B minus B is minus 1/3, so it's A minus L minus 1/3 B. That makes life slightly easier, divided by M plus M plus M, and that the whole thing is equal to 3M plus M MA plus 2MB. So cancel this and multiply by 3. So it's going to be MA minus 3ML. I'm taking this 3 and multiplying it, or multiplying the top left and right by 3. So multiply by 3 as well. ML plus 3MA minus 3ML minus MB equals MA, capital MA, plus 2MB. Yes, perfect. So MA cancels. 2MB becomes 3MB. But we need to find L, yeah? So 3ML plus 3ML equals 3MA minus 3MB. So I'm just rearranging. I hope you're all right with this. And L, well, 3L M plus M equals 3M A minus B. So from here, L is equal to 3 cancels M A minus B divided by M plus M. Perfect. Let me just check that it is in fact M divided by, yes, the answer is correct. Any questions? Any questions for this one? Now, there are 3 math questions. There are 3 maths questions. Find by integration the center of mass of the uniform triangular lamina enclosed by the lines y equals 6 minus 3x, x equals 0, and y equals 0. Okay, this is a math question, although well, it's both a math and a physics question. It's a math question in a way that there are no units, and sometimes mathematicians forget units, which is not always good. But what are we going to do? So we draw the line 6 minus 3x. So obviously that this is 6, this is 2, and the line x equals 0 and y equals 0. Oh, so these lines. So this is x equals 0 and y equals 0. So we get a triangle. But you already know that the center of mass of a triangle is 1/3 of the way from the highest point to the base. So for a triangle, the center of mass, so x center of mass, will be 1/3 of the base. So it's 1/3 times 2, which is 2/3. 2/3. Okay, I have to introduce units because meters. So 2/3 meters. So it's a large lamina. And y center of mass is 1/3 times 6, which is 2 meters. So we already solved the question, but it says by integration. Well, okay, but at least we know what we're looking for. Okay. The way they ask you to do it is not necessarily the simplest way. Well, okay, so let's start with the x-axis. finding the center of mass on the x-axis. So we're going to split this triangle into rectangles. We assume that the area density is sigma. So the area of the triangle is 6 times 2, 12, divided by 2, so 6 square meters. So the mass is sigma times area, which is 6 sigma kilograms. Density, because this is measured in kilogram per square meter. So 6 sigma kilograms. This is the mass of the triangle. Okay, so the width of, let's look at one such rectangle. Let's look at one such rectangle. So the width is delta x, the height is y, and the position, the horizontal coordinate, is x. Okay, so we have the area. So for the red rectangle, area is equal to y delta x. Mass is equal to sigma y delta x. Sigma is the area density. Mass is sigma y delta x, and the position equals x. So what we do is we have the sum of x times sigma y delta x. So we have the position times mass, and we need the sum of that. And we divide, when divided by the sum of masses, the sum of masses of the masses. Okay. I. And we limit this with delta x tends to 0. So we make the width infinitely small. And this we end up having, well, this is just the mass, the total mass. And this becomes the integral between 0 and 2 and of x sigma. Sigma is a constant, so we take it out, on y delta x, dx, sorry, dx. And we know the equation for y. Y is equal to 6 minus 3x. So we have sigma divided by the mass. We know the mass of the whole thing is 6 sigma. The integral from 0 to 2 x 6 minus 3x dx. We cancel the sigma, so it's going to be 1/6 integral. Okay, so we need to expand the bracket, so it's x squared 6x minus 3x squared. So the integral of that is 6x squared over 2 minus 3x cubed over 3. between limits 0 and 2. 0 and 2. So 1/6. Then x squared, so 4 squared. So 6 times 4 over 2. That's going to be 12. 12 minus, so 3 cancels, minus 8. That's 4/6. And that's 2/3. Voila. We actually found by integration the same thing that we already knew, which is at the same time satisfying and not. Okay, x equals 2/3 meters. Now we want to find the horizontal bit. Sorry, we want to find the vertical position of the center of mass. And for this, we're going to do a very similar thing. We're going to cut it in horizontal strips. Now, the width of the strip is going to be delta y. The xi is the width of the strip. Is the length of the strip. Sorry. And the position of the strip is yi. So the area is equal to xi delta y. Then we say the mass, mi, the mass of this bit, is equal to sigma xi delta y, and the position is yi. So we need the sum of mi yi divided by the sum of mi, and of course, okay, we're going to simplify this. The sum of sigma xi yi delta y divided by sum of mi. But we need to take the limit of that. We need to take the limit, and the limit is delta y tends to 0. So the thickness of the strip becomes smaller, smaller, and smaller. So this delta y becomes smaller, tends to 0. And if we take the limit, as you already know, but from the property of the Riemann sums, it becomes the integral. Sorry to do the same thing over and over, but it does stick with you once you've done it several times. So I do advise you to have a go and try it for yourself and convince yourself that this is true. So sigma we can take out, integral. So the y limits are from 0 to 6. Now x, we need to find x because we don't have x. So we have y is equal to 6 minus 3x. So x is equal to 6 minus y divided by 3. And we plug that in. We plug that into here. So 6 minus y divided by 3. Did I make a mistake? No, I haven't. 6 minus y times y dy. Now the integral is in terms of y. And then with the total mass, but we already know the total mass. It's 6 sigma. Nothing has changed. It's the same triangle. So we cancel the sigmas. We have 1/6. Now this integral from 0 to 6. So 6 over 3 is 2. 2 times y, it's 2y. Minus y squared over 3, minus 1/3 y squared dy. So we integrate this, so 1/6 square brackets 2y squared over 2 minus 1/3 y cubed over 3 between limits 0 and 6. We get 1/6. So 2 and 2 cancels, that's 36. 36 minus 1/9 times 216. Then that is 1/9. 1/9 times, so 1/3 times 1/3 is 1/9 times 6 cubed, which is 216. 216 divided by 9 is 24. 24, so 1/6 multiplied by 12 is 2 meters. But once again, we already knew that. 2 meters. We already found it using the properties of the triangle. The center of mass of a triangle is 1/3 of the way from the base to the opposite vertex. Any questions? Any questions? Okay. Now, for this question, I'm going to cheat a little bit, and also I'm going to show you some tricks that you can use when you're doing maths and physics, because I do encourage you to learn how to integrate, but sometimes it's much easier just to use technology to find the integral, because the definite integral has a wonderful property. It can be computed. The computers are very good at it. Okay, find the center of mass of the uniform lamina occupying the finite region bounded by the curve with equation y equals sine x and the line y equals 0. So a sketch, of course, always. So y equals sine x between 0 and pi. Well, that's just this, from 0 to pi. Okay, so that's a lamina, and line y equals 0. Okay, well that's this line. So we need the center of mass of this thing. The maximum value is 1. Y and X. Now, just by observation, because there's a line of symmetry, you can say that the X center of mass is pi over 2. Which makes your life slightly easier because you don't have to calculate the X now. So now you're stuck with the Y. Now to find the position, the Y coordinate of the center of mass, you need to cut it into horizontal strips, not vertical. So you cut it into horizontal strips. And well, okay. That does mean a few things. So, for example, this is y, yi. This is the vertical position of this strip. Then we need delta y. Delta y is the thickness. We need the length. But if this is y, then this is x. So this is x, this length is x. So the length of the strip is going to be pi minus 2x. Pi minus 2x, because it's symmetrical. Yeah, you can use the property of symmetry. Pi minus 2x. Okay. If this is pi minus 2x, then you can say, but y is equal to sine x, and x is equal to arc sine y. Well, this is true for x between 0 and pi over 2. This is true for this region. So we're only interested in this bit. And we're using symmetry. So we are actually only going from 0 to pi over 2. It won't necessarily be obvious, but hopefully I can convince you that this won't be true. Okay. So the area of the strip, the area of the blue strip, So area is equal to pi minus 2x multiplied by delta x. So the mass of the strip is going to be sigma pi minus 2x delta x once again. And the position, so mi, this is mi, and the position is yi. This is the position. Oh, sorry. What? Delta y, of course. Delta y. But also this, because x is arc sine y, it's going to be sigma pi minus 2 arc sine y. 2 minus arc sine y delta y. Now we use the formula for y center of mass. Center of mass is the sum of mi yi divided by the sum of mi. And the limit, of course, delta y tends to 0. Limit of delta y tends to 0. So the sum of mi is going to be sigma pi minus 2 arc sine y. Then y delta y. Delta y divided by the sum of mi. So to find the sum of mi, to find the mass of the whole thing, we need the area. The mass is area, so the mass is mass I, total mass. We need the area times sigma times the area. And so it's sigma times the area, and the area is the integral from 0 to pi of sine x dx. So that's sigma. The integral of sine is minus cosine x. from 0 to pi, and that is sigma minus cosine pi. It's going to be minus 1 minus 1. That is 2 sigma. 2 sigma. Okay, so we know the bottom bit. The bottom bit is 2 sigma, which makes life easier again. That is 2 sigma. And the top becomes an integral, because when you make the limit going to delta 0, it's going to be sigma that can be taken out, integral of pi minus 2 arc sine y dx, dy, sorry, dy. Now, and it goes from 0 to 1. The limits are from 0 to 1 because y goes only goes from 0 to 1. Sigma cancels. And now what I've been talking about in the beginning is that this integral is doable by all means, but I'm going to, because it's a definite integral, I'm so tempted just to use this. So this is one of the simplest calculators you can get, the Casio 991. Yeah, and all I do is I just plug in the integral 0, 1, open bracket pi minus 2 arc sine x bracket multiplied by x. So it's just this. A very simple integral. Well, it's not a simple integral. You can well, I'm doing this in terms of x because my calculator can only do it in terms of x. So I just replaced y with x. Like the integral, the beautiful thing about the integral is that if you write down from 0 to 1 pi minus 2 arc sine xi, is that xi? Oh, it's a letter times xi times dc. It will be the same thing as if you use a different any letter. Okay. Therefore, I press equals. It takes about half a minute. It's a difficult integral, so it's still calculating. It's not that powerful, but it will do it. And most of your calculators can do this. So just make sure psi. Yes, it is psi. Thank you. Psi. Well, I know what it will give me. It will give me pi over, because I've done this before. It's going to give me pi over 4. There's going to be pi over 4 divided by 2, which is pi over 8. Still calculating. I'll tell you when it's finished. Yeah, it's done. Yes, it's pi over 4. Yeah. Okay. Because if I multiply the answer by 4, I get pi. That's how I know it's pi over 4. Sometimes you need a little research. When you're expecting pi, divide the answer by pi and see if it gives you something nice. So it's pi over 8. So x center of mass is pi over 2, and y center of mass is pi over 8. It's pi over 8. Okay. Delta y. Yes, 654. Okay, the final question is, I don't think I want to go through the whole thing, but I will maybe do half the question and leave it up to you to finish it. So it has a uniform lamina occupying the finite region bounded by the x-axis, this curve, and the straight line with y equals 2x. Finding the coordinates of the center of mass. Well, to me, the easiest way is to cut it like this. Cut it like this. And you have two pieces, one with mass m1 and the coordinate r1. The second one is m2 and coordinate r2, the position r2. And the center of mass, r center of mass, is equal to m1 r1 plus m2 r2 divided by m1 plus m2. Use this formula. Then you need to find the mass. The mass of the first one, m1, is quite easy. Is well, it's the area times sigma. Yes, once again, sigma. Sigma cancels out. That's why you can. It is taken from a maths past paper. It's taken from a further maths past paper. So m1 is the area, which is 2. So this is 2, 4, 8. 2 times 4 is 8. 4 sigma. And then the x1, the coordinate of the center of mass, is 2/3 of the way. So it's 2/3 times 2 is 4/3. And y1, the y coordinate of the center. So this is the center of mass of the triangle. And this is 4/3. And this is, so this is 4. And you need a third. So it's 4/3 as well. Is 4/3. So you have the first bit. The first bit. Now for the second bit, you need to find the mass, m2. It's going to be the integral from 2 to 6 of y, so sigma, of course, times the integral from of 24 minus 4x is just the area, and you know how to find the area. It's the integral under the curve. So the area is this integral. Okay, and you can calculate that, and as a matter of fact, it's going to be 32 over 3 sigma. Now, to find x2, to find the x2 is the x center of mass of this piece of lamina, we will need an expression that goes like this. It's sigma, the integral from 2 to 6 of x multiplied by square root of 24 minus 4x, in a similar way that we did before, dx. And on the bottom we have sigma. Well, we need the mass. We need the mass, which we already know. It's 32 over 3 sigma. Sigma cancels, and this will be, and I want you to prove that. I would like you to prove that. That is 3.6. Y2, the y coordinate of this center of mass, is sigma integral from 0 to 4, because y changes from 0 to 4, of y. And now you need x. So because y is equal to square root of 24 minus 4x, 24 minus 4x equals y squared. 4x squared, 4x is equal to 24 minus y squared. So x is equal to 6 minus a quarter y squared. So that is, so y times x, so what times 6 minus a quarter y squared dy divided by the mass, and the mass, yet again is 32 over 3 sigma. So you are left with 32 to, oh sorry, 3. You're left with 3. And then you just do this, the position of the center of mass. So finally you get x center of mass. Oh, no. X center of mass is m1 x1 plus m2 x2 divided by m1 plus m2. So I'll leave this to you guys. Center of mass, and it's going to be m1 y1 plus m2 y2 divided by m1 plus m2. Complete. Okay. Okay. Now I'd like to spend some time for your questions. Any questions are welcome. So please do. It's great if you would use your voice to ask me. Use your microphone, or you can just type them in. If you have questions about the assignment,
I wanted to ask a question
Yeah.
quickly. You know how about the projectile problem that you did?
Yeah.
About where you said the center of mass is like it carries on traveling along the path of the projectile. I was just thinking, and like that's like you could also think about that with conservation of momentum, because you see what I mean? Because like the overall
Yes, the momentum,
yeah.
the total momentum remains constant if there are no external forces. Or you can say the total change in momentum is equal to the sum of the external forces times time. Yeah, so if you have the total change in momentum is equal to the total external force multiplied by delta t. And this the center of mass acts like this. Was that the question, or is it just like a comment to the first question?
Yeah, I was just wondering whether you could do the first question using the like momentum, because I thought the only external force is gravity, isn't it? So then you could say that the only change in momentum would be due to gravity. I thought you could do it like that, the question. Or...
yes, but there's no change in horizontal momentum. So from this point onwards, you can say, well, okay, the total momentum. So what happens here is that you have a projectile traveling with the speed v and mass, well, let's say mass 2m. It breaks into two, and we have a projectile of mass m traveling backwards with speed v, and another projectile mass, so minus v, and another one traveling at velocity x, for example. So before the collision, before the explosion, we have 2mv, the total momentum, and after we have minus vm plus mx, and we make them equal, because before the collision, before the explosion, the momentum before and after the explosion is the same, and you have 2mv equals mv minus mv plus mx, so 3mv equals mx, mx, so x is 3v. So what happens is you have a point in space which is some distance above the ground, here, and you have two projectiles. One is launched horizontally to the left with the speed v, and one is launched horizontally to the right with the velocity of 3v. So because they travel the same time, because the vertical movement is independent of the horizontal movement. If this travels a distance L, this travels a distance 3L. So by L, okay, L is not a very good one. If this travels a distance A, this travels a distance 3A, just because it travels 3 times faster for the same time. But then you still have to find the distance using the projectile, using the formulas for projectiles. Does that clear things up? Sorry?
Yeah, that's exactly what I meant. I was just wondering where it broke, where the like projectile broke, and how can you use momentum to try and start. Yeah, that's exactly what I meant. Yeah,
you can use momentum to find the initial velocity, but then you use the formula for projectile motion. Anyways, anything else?
Hello, sir.
Yeah.
I'm not in the course. I just wanted to ask if I can get access to like the assignment mark schemes.
So we don't do assignment mark schemes, but I am preparing answers. So you will have access to answers, and they won't be published.
Okay, thank you very much. I appreciate it.
Yeah. Unfortunately, we can't publish the mark schemes, but the answers I will give you. Yes.
Okay, thank you, Chase.
Welcome. Right. Okay, then I guess if there are no questions, enjoy the rest of the assignment. Please do submit it on time. If you can't submit it on time, do let us know so that we know when to expect your assignment. And yeah, and I'm almost done with momentum. So I hope you'll appreciate that. You're welcome. See you.